Hello everyone, welcome back to Security Architecture in the Real World series. I'm Saba, a security architect working closely with SOC and the business teams. In this series, we look at how security actually behaves inside an enterprise environment, not how it looks in diagrams or in the vendor slides usually. So today we're talking about SOC visibility in microservices environment. Now, many organizations believe that they have strong monitoring, right? But when attacks move internally, detection often completely fails. And that's the reason because we are saying this as architectural, right? So, to understand why, we need to look at how SOC monitoring was originally designed. The traditional SOC monitoring was built around the perimeter security, right? So traffic entering through firewalls, endpoint generated all the alerts, and the network boundaries defined the trust zones. Most monitoring focus on north-south traffic, means traffic entering or leaving the organization, right? So that is what usually focused. The assumption was pretty simple. Attackers come from outside. This is what many of the organization used to assume. So visibility concentrated only on the edge. That model worked in the past, right? When architecture matched it. But applications changed faster than all the detection strategies. So modern applications look very different, right? So we now have microservices, containers, so dynamic workloads, right? So that appear and disappear very quickly. Services constantly communicate with each other using APIs. Most traffic no longer crosses the perimeter at all, right? So it all happens internally. So here, east-west communication now dominates our enterprise environments. In most of the enterprise environments, it's like that now. And this is where the traditional visibility starts breaking completely. So let's look at a typical enterprise setup, right? So imagine a Kubernetes-based environment where an API gateway exposes services externally, right? So behind it, it'll have like a dozen of internal microservices itself. The namespaces what you have, those are shared. Logging is enabled. Events are all forwarded to the SIM. From a management perspective, everything looks monitored and everything looks clear, right? Even the SOC dashboard show all the activity. Alerts are configured. The confidence is pretty high as well. But believe me, the visibility is going to be shallow, right? So this actually leads to a very dangerous assumption here. Organization often say we have logs. Application logs exist, infrastructure logs exist, dashboard looks pretty healthy, but logs alone do not create detections, right? Logs without context don't explain a behavior. They record events without a meaning. And attackers operate comfortably inside that noise, right? Now, let's walk through what an actual attack looks like, right? So, here, an attacker compromises a workload, maybe through a leaked token or a vulnerable container, maybe. From that particular pod, they begin calling some internal services. The request idly look legitimate, right? So they use normal APIs, no perimeter is crossed at all, and even no malware is executed in that case, right? Eventually, the attacker reaches any sensitive service and access all the data. So data leaves using approved channels, means nothing malicious here, right? From a SOC perspective, everything will look normal because architecturally nothing appeared suspicious. So why does the detection fail here? Several architectural gaps exist, right? So to start with, workloads lack strong identity validation. Service to service communication is trusted by default. So there are no behavioral baselines for services, and the east-west traffic is not deeply inspected. Even the logs lack identity and request context. Detection rules are still endpoint focused, right? So overall, here the stock is not failing. The architecture never gave it visibility. That's how I see this. And this leads to a very common enterprise mistake. Organizations deploy SIM platforms and assume visibility is solved, right? So they collect massive amount of logs, but telemetry was never designed into the system itself. So because of that, the detection becomes reactive. Visibility is attempted after deployment instead of during the architecture design itself, and visibility cannot be retrofitted effectively, right? So what should architecture provide instead? Architectures must enable detection by design. Every service needs an identity. Service communication should be authenticated, and also it's supposed to be observable, right? And MTLS that provides both security and visibility signals. Then your distributed tracing shows the request path, right? And logs must indicate and include your identity, workload, and every request context as well. Then finally, the security telemetry becomes part of system design, not an afterthought, right? So you don't need to rebuild everything overnight. So start with your critical services, map how services communicate, and introduce the service identities gradually. Monitor any abnormal communication patterns if it exists in your environment. Then correlate identity, workload, and the request behavior. Correlate all these things together. So you will find a pattern. Then, yeah, like this, small architectural improvements dramatically increase your SOC visibility. So when done properly, the impact is significant. So SOC team begins detecting any lateral movement very early, and investigations become faster. Alerts become overall meaningful, right? So instead of just having complete noise, and the attack dwell time also reduces. Security shift from guessing to understanding it properly, and even your visibility becomes operational. It's not just theoretical, right? So this leads to the core lesson: detection is not a soft feature. It's an architectural capability by itself, right? So if telemetry and identity are not designed into the system, monitoring will always be incomplete. So security visibility starts long before an alert appears, right? So it starts at architecture. So that's it for this episode of security architecture in the real world. In the next episode, we'll look at why identities has quietly become the real enterprise perimeter. Thanks for watching.